Okay, let's talk about types of chemical reactions. The first we'll talk about is one we've been kind of talking about already, combustion and air. They're going to produce a flame. So in terms of hydrocarbons or something that's a carbon, hydrogen, and oxygen, whatever that is going to burn in the presence of oxygen to produce carbon dioxide and water, assuming it's a complete combustion. So what we want to do then is write a couple of those, and these are probably the easiest ones to write. You just have to turn around and balance them. So we're going to write combustion reactions for propane and benzene. Now with these, all you need to know is what's burning. The second reactant is always the same. So we're going to write oxygen gas, and we're going to produce carbon dioxide gas and water in the gas phase. Some people try to write that as with water in the liquid phase. That's not going to be good because there's too much heat involved. So we got 3 of those, so we're going to put a 3 there. Then we got 8 of those, so we're going to put a 4 there. So 3 times 2 is 6, plus 4 is 10. And we're going to stick a 5 there, and I think we balanced that one before. But this one is a little tougher. Still same other reactant, same 2 products. So you should be able to write one of these from scratch. It's really not that bad. So if you've got 6 of those, you go 6 there. I'm going to put a 3 there. So let's write these kind of small because we're going to have to change them. So if we put a 6 there, we put a 3 there to balance things out, I realize I'm going to end up with an odd number here. So I'm going to end up having to double that. So 2, 12, 6. Now let's get the oxygen. 24 plus 6 is 30. So I'm going to need a 15 right there. So that's combustion reactions. We've talked about them on and off over the course, but they're probably the easiest ones to write. Maybe, depending on the one, some of them might be tougher to balance, though. So let's talk a little bit about combination reactions. They're just what the name implies. You're going to form one product from 2 or more reactants. So you have that sort of formula: A plus B goes to form AB, where they come together to form one compound. There are a few basic types, but beyond those basic types, these can be difficult to predict. You can have 2 nonmetals to form a binary molecular compound, hydrogen and a halogen to form a binary acid gas, and a metal and a nonmetal to form the proper salt. So let's look at a couple of those. So let's look at these, and so if I got a metal and a nonmetal, I'm going to form the proper salt. Magnesium's in group 2, that's in oxygen's in group 6, so plus 2 minus 2 is going to be MgO. Always make sure you get the correct formula of the compound before you go trying to balance it. That's a salt, so we know it's going to be solid at room temperature, and then we just need to balance it. We're going to stick a 2 there and a 2 there to balance it. Aluminum bromide, that's in group 3, that's in group 7, so plus 3 minus 1, so it'll be AlBr3. And again, that's going to be a solid because it's a salt. So we need 2 of those, 3 of those, and then I might need 2 aluminums. H2 and Cl2, that's going to form a binary acid gas. HCl gas, hydrogen chloride, and we're just going to need to stick a 2 there to balance it. H2 and N2 will form ammonia, NH3, in the gas phase. Then we need to balance that, so we're going to need 2 of those, 3 of those, and the nitrogen's fine as it is. And so those would be some combination reactions. Okay, decomposition reactions are the opposite of combination reactions in that they are going to have one compound and it's going to break apart into smaller compounds or elements. There are a few types, but again, decompositions can get difficult to predict. Carbonates and bicarbonates will decompose when they're heated. The metal carbonate is going to form the metal oxide plus carbon dioxide. A metal bicarbonate will decompose similarly, but you'll get a metal oxide, carbon dioxide, and water vapor. Your chlorates and perchlorates will decompose, and you'll form a chloride salt and oxygen gas. The stoichiometry would just be different whether you're talking about a chlorate or a perchlorate. And so then we want to look at some of these decomposition reactions, and we're going to try to write each one. Okay, so let's look at these reactions. Now remember, this is going to decompose to form a metal oxide, so it's going to be calcium with oxygen, so group 2A and 6A plus 2 minus 2. So that's going to work out as is, and then it's going to produce carbon dioxide gas. Then we need to check the balance. 1 calcium, 1 calcium, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. So that's balanced without adding any coefficients. Now let's look at the bicarbonate. You're going to get a metal oxide. You're going to put sodium with oxygen, but in this case, that's group 1 and group 6, so plus 1 minus 2, so it's going to be Na2O solid. And we're going to form carbon dioxide gas, and we're going to end up with some water vapor. And we're going to have to end up balancing that. So I've got 2 hydrogens, so I'm going to have to double all this, and that'll take care of my sodium and my hydrogen. Now, the carbon, there's 2 of those, so I'm going to need 2 CO2s. Now let's check our oxygen balance. So there's 6, so there's 1, 2 times 2 is 4, plus 1, so there's 6 oxygens. So that reaction is balanced how it is. Now let's go to the chlorates and perchlorates. That's going to form a metal chloride. So KCl plus 1 minus 1. So that's good. I mean the solid phase. And it's going to liberate oxygen gas, O2. That's where it's particularly important to start remembering your diatomic elements because they'll be given off from some of these reactions. So let's balance. I might need to balance that oxygen, so I'm going to go 3 there, 2 there, and that makes me put a 2 there. And then for the calcium perchlorate, it's going to be calcium chloride, so Ca with Cl, but that's plus 2 because it's in group 2, minus 1 for halogen. So it's going to be CaCl2 solid plus, now it's going to liberate some oxygen. I've got 2 times 4 is 8 oxygen, so I'm going to have O2. So I'm going to put a 4 there, so 4O2 gas. And those would be decomposition reactions. There are others, but some of them can be complicated to predict the products of.